This is Prost's hypothesis. According to this, he assumed simply all the elements are made up of hydrogen atoms, so that the atomic weight of element is equal to small n into atomic weight of one hydrogen atom, so that where n represents number of hydrogen atoms. So in such a way, he assumed. After that, we discussed Daubeney triad. Triad nothing but group of three elements having similar properties. And he said the atomic weight of middle element is mean of other two elements. For example, we explained the group of three elements like lithium, sodium, potassium. The atomic weight of sodium is mean of other two elements like lithium and sodium. So these are called as Daubeney. But what is the drawback of this triad? He could not arrange all the elements in such a manner like triad. He arranged only few elements. It is impossible for all the elements existed as or arranged as a triad. This is one of the drawbacks. Not only that, but also one of the triad like nickel, cobalt, iron, cobalt, nickel is having similar atomic weight. It is not strictly followed, so that it was rejected. Prost's hypothesis also rejected due to the reason of all the elements are not made up of hydrogen atom. Not only that, but also hydrogen atomic weight is 1. So 1 into n nothing but where the total atomic element should be whole number. But most of the elements like sodium atomic weight is 35.5, francium 87.5, nothing but some of the elements atomic weights are fractional values like 35.5, 87.5. But if we said, according to Prost's hypothesis, where atomic weight of element is equal to n into atomic weight of hydrogen. N nothing but number of hydrogen atoms. It is integer value as well as atomic weight of hydrogen also 1. So the whole value will be whole number. But it is not strictly followed, so that was also rejected. After that, we discussed Newland's law of octet. So he arranged all the elements with increasing order of their atomic weight, and he observed one point: every 8 element is having similar properties like first element. It is like 8 note in musical scale, like a sarigama padanisa. So he arranged lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and sodium. Every 8 element like sodium as well as lithium are having similar properties. 8 element is having similar properties like first element, and potassium is having similar properties like sodium. So these are the final conclusion is every 8 element is having similar properties like first one. So why it is rejected? Why it is rejected? Generally, he could not arrange all the elements, all the known elements in such a way with increasing order of their atomic weight. Not only that, but also he arranged few elements up to atomic number 20 up to calcium. Not only that, but also at the time of Newland's law of octet, there was no discovery of inert gases. So that only I took lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. After that, directly I took sodium. Why? Because there is no neon, there is no discovery of, there were no discovery of what is that? Inert gases or zero group elements till then. So it was one of the drawbacks, so that it was rejected. Then after that, we discussed Lothar Mayer's curve. Lothar Mayer is one of the scientists. So he plotted a graph between atomic volume and atomic weight. And he made some of the conclusions, some of the observations. Those observations are most of the electropositive elements those are alkali metals. Those are first year group elements. Those are lithium, sodium, potassium, rubidium, cesium, and francium. Most electropositive elements are occupy peak position on the curve. And the less electropositive elements like beryllium, magnesium, calcium, francium, barium, radium, those occupy descending order on the curve. And most of the metalloids like silicon, arsenic, and antimony, and astatine, and most of the transitional metals, metalloids and transitional metals occupy bottom of the curve. And one more important conclusion was, what is that? He made one more observation, that is most of the electronegative elements like fluorine, chlorine, bromine, iodine occupies ascending order on the curve, ascending position on the curve. These are the observations he made, and finally he said, I'm going to draw the graph also. On the y-axis, on the y-axis, it took atomic volume. Atomic volume. On x-axis, it took atomic mass. Atomic mass. And if plot a graph between atomic volumes as well as atomic mass, the curve will be we can write like this. This was the curve between atomic volumes as well as atomic mass. Most of the electropositive elements occupy peak position on the curve. These are the peak position on the curve. These peak positions are occupied by most electropositive elements like first group elements, those only called as alkali metals like lithium, sodium, potassium, rubidium, and cesium. And less electropositive elements, alkaline earth metals, occupies descending order on the curve. This is the descending order, decreasing order. Those are like beryllium, magnesium, calcium, strontium, barium. This is a descending order, decreasing order. Most of the metalloids as well as transitional elements occupy bottom of the curve. This is the bottom position of the curve. Like I take here nickel, cobalt. Not only that, but also you can take it other elements: silicon, arsenic, nickel, cobalt, ruthenium, Ru, rhodium. We can take it here some of the other elements like At or any other elements, palladium, and so on. Palladium and so on. And one more point is the most electronegative elements like fluorine. This is the ascending order. This is ascending order, increasing order. This is ascending order. Most of the electronegative elements occupies ascending order on the curve. This is ascending order or increasing order. Fluorine, chlorine, bromine, iodine. So what I like to tell you, on this curve, peak positions occupied by most electropositive elements, those are alkali metals. Descending order positions occupied by alkaline earth metal, less electropositive elements. Bottom positions are, I given few examples only. There are many transition metals are there, D block elements. There are many metalloids also present. Few among them I took as an example. Please consider. Here, like metalloids and transition metals occupy bottom positions on the curve, and most electronegativity elements, those are 7th group elements, those are halogens, occupy ascending order on the position. So finally, what he made a conclusion, the note, the elements which are having similar properties occupy similar position. So here the peak positions are lithium, sodium, potassium, rubidium. These are the peak positions, similar positions, so that all lithium, sodium, potassium, rubidiums are having similar properties. Here beryllium, magnesium, calcium, all of them are occupying descending positions, so that those are having similar position, similar properties. The elements which are having similar positions have similar properties. This is the conclusion. Not only that, but also He made one more conclusion on the basis of Kerr. He proposed one law. He proposed that the physical properties of elements are periodic functions of their atomic weight. It's a very, very important. On the basis of this curve, he proposed that the physical properties of elements are periodic functions of their atomic weight. Why this is very important? This becomes base of Mendeleev periodic table. Mendeleev periodic table and modern periodic tables are very, very important for competitive exam. These all of them are earlier, these are basics which are before Mendeleev periodic table as well as modern periodic table. So that I said these are the development of periodic table. So what are the conclusion finally? Conclusion is on the basis of the curve, Mendeleev, Lothar Meyer proposed that the physical properties of elements, are the periodic functions of their atomic weight. Periodic function of their atomic weight. Their atomic weight. What is it? The periodic properties of elements are the physical properties of elements are periodic functions of their atomic weight. And also one more point, and taking, please note it. It becomes base of Mendeleev periodic table. Whatever given, whatever he proposed law, the physical properties of elements are periodic properties of the physical properties of elements are periodic functions of their atomic weight, and it becomes base of Mendeleev periodic table. Okay. CD students, Mendeleev periodic table is one of the very important periodic table. There may be a question they may ask some questions from Mendeleev periodic table in competitive exam. Mendeleev periodic table as well as modern periodic tables are very, very important that we are going to discuss now. What is the Mendeleev periodic table? The Mendeleev periodic table is based on atomic weight. First of all, the Mendeleev periodic table is based on atomic weight. And Mendeleev proposed one law that is called as periodic law. What is the Mendeleev periodic law? The physical and chemical properties of elements are periodic functions of their atomic weight. Once again, the physical and chemical properties of elements are periodic functions of their atomic weight. He arranged all the elements with increasing order of their atomic weight up to atomic number 63. Nothing but he was the first scientist. He was the first scientist arranged all known 63 elements in such a manner systematically as like vertical columns as well as rows. He was the first scientist arranged all 63 elements in a systematic manner like horizontal rows as well as vertical columns, so that Mendeleev is known as father of periodic table. Mendeleev is the father of periodic table. He was the first scientist to classify all the known elements in such a systematic manner like horizontal rows as well as vertical columns. Those vertical columns only called as groups. Horizontal rows only called as periods. In this Mendeleev periodic table, there were 7 horizontal rows are there. There were 7 periods are present. In Mendeleev periodic table, there were only 8 vertical columns are present. Those 8 vertical columns are called as groups. Those 8 vertical columns also further divided into 2 parts, like each group up to 7. Each group up to 7 divided into subgroup A and B. Subgroup A is for only normal elements. Subgroup B for transitional elements. There are only 8 groups are present. Among them, each group up to 7, except 8, up to 7 subdivided into 2 groups. Those are called as subgroup A and subgroup B. Subgroup A for normal elements, subgroup B for transitional elements. And the 8th group contains 9 elements in 3 positions, 3 horizontal rows. That group is called as transitional metal groups. Once again, I am repeating. The Mendeleev periodic law is based on atomic weight. The Mendeleev periodic law is the physical and chemical properties of elements or periodic functions of their atomic weight. He was the first scientist to classify all the elements, nothing but all known 63 elements in a systematic manner, like horizontal rows as well as vertical columns. Horizontal rows are called as periods. There were 7 periods are present in Mendeleev periodic table. Vertical columns are called as groups. There were 8 groups were there in Mendeleev periodic table. Among 8 groups also, each group up to 7 subdivided into A as well as B, subgroup A and subgroup B. Subgroup A elements are called as normal elements. Subgroup B elements are transitional elements. Then that 8 group contains 9 elements in 3 positions in 3 horizontal rows. That group only called as transitional metal groups. Okay, there are some demerits, there are some advantages are there as well as disadvantages also there that we discuss later. First we read. For a Mendeleev periodic table, it is based on atomic weight, of the element, and next one is Mendeleev periodic law. Mendeleev's periodic law. What is the Mendeleev periodic law? The physical and chemical properties of elements the physical and chemical properties of element or periodic function of their atomic weight. Their atomic weight. And he was the first scientist to classify all the non-63 elements in systematic manner, so that the father of periodic table is Mendeleev. The characteristics of Mendeleev periodic table. What are the characteristics? He was the first scientist to classify all non 63 elements. At the time of Mendeleev periodic table, non-elements are 63 only, not 118. Non-elements are only 63. Those are systematically arranged. All non-63 elements are arranged. All non-63 elements, we classify all non-63 elements in a systematic manner. Like horizontal rows and vertical columns. Okay. Further, those horizontal rows only called as periods. Further, those horizontal rows only called as periods. The horizontal rows are known as or called as periods. And there were 7 periods in Mendeleev periodic table. In Mendeleev periodic table. The vertical columns only called as the vertical columns are known as groups. Then how many groups are there in the periodic table? In this periodic table, there are only 8. CDS student, don't compare with present form of periodic table. In the present form of periodic table, there are 18 groups are there, 7 horizontal periods are present. But do not compare with long form of periodic table or present form of periodic table. It was Mendeleev periodic table, earlier periodic table before long form of periodic table. So at the time of Mendeleev, there are only 8 groups are present. Groups, and there were 8 groups are present. There were 8 groups in Mendeleev periodic table. Those 8 groups also further divided into subgroups. Each group up to 7. Generally, 8 groups are represented like Roman letter. First year, second year, third year, like 8th year in Roman letter. Up to 7 groups divided into A and B subgroups, and subgroup A only for normal metals, only for normal elements, not metals, normal elements. And what are the normal metals, normal elements, and transitional elements that we discuss further lecture? So subgroup A only for normal elements. That point you should know. And subgroup B only for transitional elements. CDS students, you don't need to bother about what are the normal elements as well as transitional elements. There are types of elements are present in our periodic table. So it comes further lecture like normal elements, representative elements, and inert gases, D block element, transitional elements, inner transitional elements. There are 4 types of elements are there like normal elements, inert gases, transitional elements, inner transitional elements. Those will come in further lecture. You don't need to bother. But the A subgroup is only for normal elements. B subgroup is for transitional elements. These are up to 7 groups only. There is remaining group is 8 group. Here the 8th group contains Age group contains age group consists of how many elements? 9 elements in 3 positions. In 3 positions or 3 horizontal rows. In 3 horizontal rows. Those only called as transitional metal groups. Transitional metal group. Age group is known as transitional metal group. Nothing but generally one element occupies only one position. But in the case of Mendeleev periodic table, age group occupies 9 elements in 3 positions, 3 horizontal rows. In the 3 positions, 9 elements are occupied. So that is only called as horizontal. That is only called as that group. Age group of Mendeleev periodic table only called as transitional metal groups. Transitional metal groups. There are some merits. This is the classification of periodic table of Mendeleev periodic table. There are some merits as well as demerits also, advantages and drawbacks. First, we discuss what are the advantages of Mendeleev periodic table. Or advantages of Mendeleev periodic table. Mendeleev periodic table. What are the advantages? You are the first scientist to classify all the elements in a systematic manner as like groups according to similar properties of their elements. So that the study of properties of elements becomes very easier. Once again, I repeat, first advantage is study of elements, study of properties of elements. The study of properties of elements become easier due to Mendeleev periodic table. How? He classified all the elements, he classified some elements in a group according to similar properties. So the study of physical properties of elements become easier. Nothing but the elements which are having same properties, those are arranged as a group. Those are classified as a group. For example, first year group elements are all first year group elements are having same properties. We don't need to study individual properties of elements. All first year group elements having similar properties. All second year group elements having similar properties. Nothing but first time he arranged all the elements in group according to similar properties, so that the study of properties of elements become easier as compared to earlier. Not only that, but also he arranged, what is that? There is another advantage. That advantage is correction of atomic mass. What is that? Correction of atomic mass. There was some correction of atomic masses. Generally, beryllium atomic mass is 9, but before correction, the beryllium atomic mass is 13.5. How it will be? Correction of atomic mass of elements. The beryllium equivalent, atomic mass is equal to valency into, what is that? Valency into equivalent mass. This is the formula. Atomic mass is equal to valency into equivalent mass. The equivalent mass of beryllium is 4.5 and beryllium valence is 3. So by using formula, atomic mass is equal to valence into equivalent mass. Here 3 into 4.5 becomes 13.5. There is no gap for periodic table. There is no gap. There is no particular place in this Mendeleev periodic table for beryllium. Why? Because beryllium atomic weight is 13.5. It was not correct. So that he corrected some of the elements atomic mass. How he corrected? After correction, the atomic mass of beryllium is 9. How we got? The equivalent weight of beryllium is same as earlier also. The equivalent weight of beryllium is 4.5 only. But the valency of beryllium is corrected to 2. The valence of beryllium is 2 and equivalent weight is 4.5. The atomic weight is equal to 2 into 4.5, which is equal to 9. Before correction, atomic weight of beryllium is 13.5. After correction, atomic weight of beryllium is 9. So before correction, there is no space, there is no place for beryllium in Mendeleev periodic table. After correction of beryllium atomic weight, there is a position, there is a space for beryllium between lithium and boron. Okay, lithium and boron. In such a way, he corrected some of the elements atomic weight. Atomic weight formula is equal to valence into equivalent mass. By using this formula, he corrected some of the elements atomic weight. Best examples are there may be a chance to ask this question: which elements are corrected by using Mendeleev periodic table? Examples are beryllium, uranium, platinum, rhodium, and unbium. I'll give the examples also. What are the another advantage is he gave an encouragement for new discovery of new elements. This is one of the most important advantage and merit. He gave an advantage. He gave an encouragement for discovery of new elements. What he did for that? He left some gaps in their periodic table. He gave an encouragement for new elements, discovery of new elements, so that he left some gaps, some vacant position in their Mendeleev periodic table. After that, those gaps are discovered, those elements are discovered, those gaps names also provided. Those are like whatever he left the gap, whatever he left the position, those positions name also is given like Eka boron. Now Eka boron is called as scandium. Another gap name is Eka aluminum. Now whatever the element is discovered in the place of Eka aluminum, that is called as gallium. Eka silicon. Now that vacant space, vacant gap name was Eka silicon. Now whatever the element is discovered in that place, that element is germanium. And another element is Eka manganese. Now that element is technetium. So once again I am repeating, there are three advantages are there. First advantage is, there was the first advantage, that advantage was, what is that? He gave an advantage, he gave an encouragement for discovery of new elements, so that he left some gaps in Mendeleev periodic table. He gave some names for those gaps like Eka boron. Now it is called as scandium. Eka manganese. Now it is called as technetium. Eka silicon. Now it is called as gallium. Sorry, Eka silicon. Now it is called as germanium. Eka aluminum. Now it is called as gallium. Eka boron, scandium. Eka aluminum, gallium. Eka silicon, What is that? Germanium. Eka manganese. Now it is called as technetium. Along with that, first time he made all elements in systematic way like a group, so that those groups also based on similar properties. So the study of properties of elements become easier. This is the one of the advantage of Mendeleev periodic table. Last one is correction of atomic weight. Atomic weight formula is valence into equivalent mass. But some of the elements are not having correct atomic weight, like beryllium is the best example. Before correction, atomic weight of beryllium is 13.5. So there is no particular position in the Mendeleev periodic table. After correction, the atomic weight of beryllium is 9. There is a particular position for beryllium between boron and lithium. Like that, if corrected some of the elements like uranium, platinum, rhodium, and beryllium. These are the examples which atomic weights are corrected. So these are the three advantages, my dear students. First one is study of elements, study of properties of elements. Study of properties of elements. First time arrange first time he arranged all elements nothing but all non-elements. How many non-elements? Up 63 elements only non in periodic table. What is that? Mendeleev periodic table. All non-elements in a group according to their similar properties. Nothing but which are having same properties, those are classified as a group. So the study of properties of elements become easier. This is one of the most advantage of Mendeleev periodic table. Next one is he gave a encouragement for discovery of new elements. It is one of the extraordinary advantage of periodic table. You must remember those 4 gap names like Eka boron, Eka aluminum, Eka silicon, Eka manganese. Those are the very, very important. Another one is discovery of new elements. Discovery of new elements. He gave encouragement for discovery of new elements new element. So you gave an encouragement for discover of new element. How you gave the encouragement? You just left some vacant spaces. You just left some gaps in his periodic table. That is the only advantage. That is only the encouragement of discovery of new element. What he did? So he left new element, encouragement of new elements. So he left some gaps, nothing but vacant position in his periodic table. Along with that, whatever he left, those gaps also given some names. Whatever he left, for those gaps, he gave some names. Those names are like Eka boron. This is a very, very important Eka boron. Now it is calling as scandium. Symbol of scandium is SC. Another gap name, Eka aluminum. Now it is calling like gallium. The symbol of gallium is Ga. Eka silicon. Now it is calling like germanium. The symbol of germanium is capital G subscript E. Last one is Eka manganese. Eka manganese. Now this is known as technetium. The symbol of this one is T. So these are the names. Please note it first. Please correct this aluminium. Okay. So these are the discovery of new elements. The last one is correction of elements, also very important. It's not there in some of the books also. Correction of elements. How the correction of atomic weights of elements. Third one. Correction of atomic weights he corrected atomic weights of some elements. some element. I am giving some examples. What are the examples? Best example is beryllium. Example is beryllium. The equivalent here, the equivalent weight of beryllium is 4.5, and valency of beryllium is 3. Valency of beryllium. See, the equivalent weight of beryllium is 4.5 and valency of beryllium is 3. Then atomic weight formula. What is the atomic weight formula? Atomic weight is equal to valency into equivalent weight. Then how much we are going to get? Atomic weight of beryllium is equal to valency of beryllium is before correction 3 and equivalent weight is equal to how much? 4.5. It is equal to 13.5. So now atomic weight of beryllium is 13.5. There is no gap before correction. Atomic weight of beryllium is 13.5. So there were no gap, nothing but no position, no gap or position for beryllium in Mendeleev periodic table. Mendeleev periodic table. There was no gap for Mendeleev periodic table. After correction, the equivalent weight of beryllium is same as like earlier, which is 4.5, and the valency is 2. Then atomic weight of beryllium becomes 9. How much it is? Atomic weight is equal to valency into equivalent weight. It is equal to 2 into 4.5. This is equal to how much? 9. Now there is a gap. After correction, atomic weight of beryllium is 9. After correction, the beryllium atomic weight is 9. There is a position, particular position or gap for beryllium in its periodic table, in Mendeleev periodic table, that is between lithium and boron. So there is a gap or position. There is a particular position or gap or position for beryllium in Mendeleev periodic table. Mendeleev periodic table in Mendeleev periodic table between lithium and boron. So these are the demerits of Mendeleev periodic table. Sorry, these are the merits and advantages of Mendeleev periodic table. And I'm going to give what are the drawbacks, whatever the disadvantages also. Notes we'll take tomorrow. I'm explaining what are the demerits, what are the drawbacks of Mendeleev periodic table. There were no discovery of inert gases. That is one of the most drawbacks. There were no discovery of inert gases till then. That is one of the drawbacks. Not only that, but also one more important point is there is no certain position for hydrogen in its periodic table. There were no certain position, particular position for hydrogen in Mendeleev periodic table. Hydrogen is placed even in first year group element as well as what is that seventh year group element, because due to resemble properties, due to similar properties of first year group as well as seventh year group. This is the one of the drawbacks. And Mendeleev periodic table is based on atomic weight. Here write all the known elements with increasing order of their atomic weight, but it is not strictly followed. Mendeleev periodic table is depends on based on atomic weight. He arranged all the elements with increasing order of their atomic weight, but it is not strictly followed. Some of the elements I am going to give, where potassium is there as well as argon also present. Argon atomic number is 18, atomic weight is 40. Potassium atomic number is 19, and their atomic mass of potassium is 39. So the atomic weight lesser element should come first, then after that more atomic weight element. But there is a reverse. It is not strictly followed. Atomic weight argon is 40, it comes first as compared to atomic weight 39 potassium. Argon comes first after potassium. See, there is order is not strictly followed. Atomic weight is more even it comes first. Along with that, there is no particular position for isotopes. Isotopes are having different masses. Hydrogen, deuterium, and tritium. Protium, deuterium, tritium. Those are having different atomic masses, so that there is no gap, there is no position. If it is strictly followed, there should be a position for isotopes also. Why? Because isotopes are having different atomic masses. First drawback is there is no position for particular position for hydrogen. It is placed in both first year group as well as seventh year group. And there is no position for isotopes which are having different masses. And where the atomic mass increasing order of atomic weight is not strictly followed. Not only that, but also what is that I said there is no particular gap for isotopes as well as those hydrogen atoms. So I hope you understood well. I will discuss this demerits tomorrow also. Thank you so much.